I'm going to talk about heaps. I'm going to describe what they are, how they're built, and a little bit about how we can use them. So first off, what is a heap? Well, a heap is a nearly complete binary tree. So let me just draw what this means real quick. So we know a binary tree is something like this. It's, a bunch of nodes connected to each other with these kind of segments, and each node has at most 2 children. Well, a nearly complete binary tree is something like this, where we can have one node that has less than 2 children. Still can't have more than 2, but you can have less. So something like this, for example. And we'll see why this is used in just a moment. So this is a nearly complete binary tree, but what's a heap? What's the difference between this and a heap? Well, a heap has, just like a tree, values stored within it like this. Let me just add some random values in here. That's a 5. Okay. So the heap has something called the heap property. Now this means that this top node is special. It has to either hold the largest or the smallest number in the set. So in this case, it holds the smallest number, 1. And if it was, this is what's called a minimum heap, because the minimum number is on the top. If this were a maximum heap, then this would, this here would be a 6. This would be the largest number in the set. And I guess we could swap these two and then make it a maximum heap. The ordering of the other nodes don't really matter. It's not like a special ordering or anything like that. All that you care about is this top one right here. And this is a minimum heap. Okay. So how are heaps built? Well, they're usually built atop a priority queue. So it's just like a regular queue where you have elements kind of like an array like this. And you enter from the back here and you leave from the front. Except that this here is the most extreme value, the smallest or largest. This is the top of the queue, the top of the tree here. And elements are added kind of based on their rank. So in this case, it's how small a number is. The smaller a number, the higher the rank. And if it's the smallest, it ends up right here. But this is kind of more of a low-level thing. What's really important to understand is maybe heapify. Heapify is the function that can transform a regular old nearly complete binary tree into either a maximum or a minimum heap. So I'll demonstrate that really quick. It's pretty simple. So let's say this 1 and this 4 were swapped. So here is a nearly complete binary tree. It's not a heap, as you can tell, because 4 is neither the largest or smallest number, just a nearly complete binary tree. So how would we turn this into a heap? Well, most heaps, or if you're implementing a heap yourself, most heaps have a function called heapify, which transforms something like this into a heap. And how does it do it? Well, it basically goes through and finds the smallest element. In this case, it's 1. Pretty simple, and it just puts it up here on the very top in the front of the priority queue. So this would be a pretty simple operation. It would just be swapping these two things. Okay, and so something that's really useful about heaps is that you can find the largest or smallest numbers in a set pretty easily. So say we have some set like this one, and we want to find the 3rd smallest number in the set. Well, we can do this pretty easily using a minimum heap. So what we would do essentially is, well, here's the smallest number right now. We could remove this and then re-heapify the remaining nodes, and we would end up with a heap with the 2nd smallest number on the top because we removed this one already. So let's demonstrate this. The way that we typically remove elements from a heap is you swap it with one of the leaves, like this one, So let's put the 4 up here. And then we can simply remove this node from the tree. And there, we've reduced the number of elements in the set by 1 and deleted the smallest element. So now we can find the second smallest element. Well, how do we do that? Well, we just need to call heapify on this remaining tree. So if we call heapify, I'm not going to go into how heapify works. It can be implemented recursively. That's probably the best way to do it. You can simply just expect that heapify will return something like this, where 2 and the 4 are swapped, or maybe it's not just a swap, but one thing you can definitely count on is that 2, the second smallest number, is going to be up here. And now we can extract 2, so we can remove this by doing a similar operation. Maybe we can swap it with this number, this leaf node. Okay, and then remove this one. There we go. Now we're looking for the third smallest number. Well, we call heapify on this remaining heap, and it determines that this is the smallest number. It just keeps it where it is, or maybe swaps it with itself, and then we have this. This is the third smallest number. So in total, we called heapify twice, and we removed 2 of the top elements. So this is the third smallest element, and that's what we were looking for. So 3 is the third smallest. Okay, now let's see maybe a problem where this can be used. So here's a medium LeetCode problem, and it's asking us essentially to find the kth most frequent element. So you can see this is kind of like finding the kth largest element in a set. So what is this frequent elements thing? Well, it doesn't really, don't want to get too in depth with it, but essentially you have an array like this, and you want to find the number with the kth most repeats. So if it's the first most repeats, in this case we would return 1, since there's 3 1s. If it's the second most repeats, we'd return 2, since there's 2 2s. Third most would be 3, etc. So this can be as simple as, counting the number of repeats that a certain number has and pairing it with that number. So 1 would be paired with 3, 2 would be paired with 2, 3 would be paired with 1, and then you can make a heap out of those associated values, and then just do essentially what we did back here, where we remove the top number a specific number of times, each time calling heapify again, so that we can get another heap that would reserve the heap property and give us the smallest number again. And then we can simply find what number that's associated with this within this array, and we would have our kth largest or smallest element. Say maybe you want to find the largest element of a series of numbers that were inputted by the user. You could do something similar in that regard, where every element that you insert goes into a heap, like a maximum heap. And then at the end of that input, you would just take the top number off of the heap, because that number is guaranteed to be either the smallest or the largest number. And so those are a few examples of how we can use heaps in practice.